Hello again, everyone. This is Mr. Hoy. In this question, we'll be constructing a table using the starting point and the next three integer coordinates. I'll talk more about that in a moment. But the next three integer coordinates that could be used to graph the following function. All right, so the beginning of the question is the same as the previous questions, where you're just looking to find the starting point. To find the starting point, you're looking to make the area under the radical 0. What that means in our case here is we want an x value of 2. Plug in the x value of 2, we get 2 minus 2 being 0, and the square root of 0 is also 0. So again, this is our starting point right here, and we just want to go on to doing a few more points after that. In terms of what we have to decide here with our integer coordinates, the first decision was relatively easy. We want to have the square root of 0 because we know that's 0. After that, we want to focus on our perfect squares. Our next perfect square here is going to be 1. We'll follow that by looking for the perfect square of 4, and then the perfect square of 9. We're dealing with those numbers because the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. And we're looking to get these integers that come from our calculation. So what we want to do, we want to start looking for this point. Instead of focusing on a 0, we want to focus on getting a 1. To do that, we're looking at x minus 2, and we want that to be equal to 1. So that would make x positive 3. Plug in positive 3. 3 minus 2 is 1, and the square root of 1 is also 1. We'll move on from there to finding 2. And to get to 2, we need to first get the area under the radical equal to 4. For that to be the case, we're going to need to have x being 6, because x minus 2 equal to 4 makes x equal to positive 6. So here's the positive 6. 6 minus 2 equals 4, and the square root of 4 is 2. Move on from there for our fourth point. We need the area under the radical to be 9. So we need x minus 2 to equal 9. To get there, we're going to need x to be 11. Plugging in 11 minus 2 gives us the square root of 9, and that gives us positive 3. So our final point is 11, 3. To show how that looks on a graph, our starting point of 2, 0 is right there. We then have 3, 1, 6, 2, and 11, 3, giving us that square root function we're used to seeing. I would recommend when you're doing these tables to do a quick graph after that, just to make sure that the curve makes sense in the situation. If you see this square root function starting to curve back upward or downward or some other direction, you'll realize that you made a mistake and you can go back and make that correction.